Book 1 Advanced College Q. Advanced College Semester Course, Toroidal Cosmology of Vibes of the Cosmos Book. Course title: Unveiling the Ethereal Tapestry, a dissertation-level exploration of vibes of the Cosmos Book 1. Level Advanced College Upper Undergraduate Graduate Seminar. Objective: master the geocentric toroidal field cosmology of Book 1 through rigorous analysis, synthesizing its flat Earth framework, ether physics, and 7 ceilings into a unified model, preparing students for original research or interdisciplinary applications. Duration: 15 weeks, 3 hours week, 45 hours total. Prerequisites: college-level physics, electromagnetism, waves, critical thinking, familiarity with alternative cosmologies. Materials: Vibes of the Cosmos Book 1 pages 1 to 88. Notebook. Access to graphing tools optional. Course structure: in-depth bullet point summary with 17 khandas per point. Each of the 5 points from Book 1 is expanded into a 3-week module, with 17 khandas per point to drive advanced inquiry. Page references are drawn from the Book 1 backpack document. Module 1 Geocentrism and the Flat Earth Foundation, pages 1 to 34. Content: Earth is a stationary, flat plane at the universe's center, enveloped by a primary toroidal field pulsing energy for cosmic seasons. Hidden continents are ethereal imprints in outer zones, magnetic north shifts with field realignment, and time zones arise from electromagnetic currents. Toroidal lens: the flat Earth anchors the base toroidal field, organizing surface and temporal cycles. Key takeaway: the toroidal field is the foundational energy structure of this cosmos. 17 advanced khandas. Q. How does the toroidal field's Gaussian curvature generate seasonal energy pulses? A. It creates rhythmic electromagnetic gradients across the flat plane, driving seasonal shifts, pages 1 to 34. What distinguishes hidden continents as ethereal imprints from physical landmasses? A. Their energy signatures in the toroidal field's outer zones, not solid terrain, pages 1 to 34. Q. How does magnetic north shift correlate with the toroidal field's realignment? A. Field oscillations adjust the magnetic axis, reflecting energy flow changes, pages 1 to 34. Q. Why do time zones emerge from electromagnetic currents rather than solar position? A. The toroidal field's rhythmic pulses segment the plane into temporal zones, pages 1 to 34. Q. How might the flat Earth's stationarity challenge Newtonian mechanics? A. It rejects orbital motion, relying on ethereal energy for phenomena, pages 1 to 34. Q. What role does the ether play in conducting seasonal energy across the plane? A. It acts as a fluid medium, channeling toroidal currents, pages 1 to 34. Q. How could hidden continents' imprints be empirically detected? A. By mapping ethereal energy anomalies in the outer zones, pages 1 to 34. Q. What implications does magnetic north's mobility have for navigation? A. It suggests a dynamic compass tied to field shifts, not a fixed pole, pages 1 to 34. Q. How do toroidal currents create distinct time zones without a rotating Earth? A. They establish standing waves of energy, segmenting the plane, pages 1 to 34. Q. What physical properties might the ether exhibit to support this model? A. Fluidity and conductivity, enabling energy transfer, pages 1 to 34. Q. How does this framework redefine the concept of center in cosmology? A. It positions Earth as the energetic hub of toroidal layers, pages 1 to 34. Q. Could the toroidal field's pulses influence climate beyond seasons? A. Yes, by modulating ethereal energy distribution, pages 1 to 34. Q. How might hidden continents relate to historical maps or myths? A. As energy imprints, they could align with lost lands like Atlantis, pages 1 to 34. Q. What mathematical model could describe the toroidal field's energy flow? A. A Gaussian distribution of electromagnetic potential, pages 1 to 34. Q. How does this model explain geological features on a flat plane? A. Through ethereal imprints shaping terrain via energy gradients, pages 1 to 34. Q. What experimental design could test the toroidal field's seasonal effects? A. Measure electromagnetic fluctuations across the plane over time, pages 1 to 34. Q. How does geocentrism shift our understanding of cosmic scale? A. It compresses the universe into a layered toroidal system centered on Earth, pages 1 to 34. Module 2, Structured Cosmos Above, World Map and Constellations, pages 35 to 66. Content: The world map reflects toroidal energy patterns, with many Antarcticas as outer ethereal zones. The constellation circle is a higher toroidal layer, where stars form as electromagnetic imprints via Gaussian curvature. Toroidal lens: toroidal fields project and organize the cosmic structure above. Key takeaway: celestial phenomena are ethereal projections within layered fields. 17 advanced khandas. Q. How does the world map encode toroidal energy patterns? A. It reflects electromagnetic gradients shaping geography, pages 35 to 66. Q. What defines many Antarcticas as distinct ethereal zones? A. Unique energy signatures in the toroidal field's outer ring, pages 35 to 66. Q. How does Gaussian curvature shape the constellation circle? A. It focuses electrical currents into stable star imprints, pages 35 to 66. Q. Why are stars considered electromagnetic imprints rather than physical bodies? A. Their energy concentrations within the toroidal field, pages 35 to 66. Q. How does the toroidal field project the cosmos above a flat Earth? A. By layering ethereal energy into visible patterns, pages 35 to 66. Q. What role does the ether play in stabilizing constellation imprints? A. It conducts currents, maintaining their form, pages 35 to 66. Q. How might the world map's energy patterns influence climate zones? A. By channeling ethereal flows that affect temperature, pages 35 to 66. Could many Antarctica's imprints be mapped using modern tools? A. Yes, via electromagnetic field detectors, pages 35 to 66. What distinguishes the constellation circle as a higher toroidal layer? A. Its elevated energy density and curvature, pages 35 to 66. Q. How does this model challenge heliocentric star formation theories? A. It replaces fusion with ethereal energy imprints, pages 35 to 66. Q. What mathematical function describes Gaussian curvature here? A. A toroidal field equation with radial symmetry, pages 35 to 66. Q. How do constellations' fixed nature align with a dynamic ether? A. The ether's fluidity sustains stable energy nodes, pages 35 to 66. Q. Could the world map reveal hidden energy anomalies? A. Yes, in zones like many Antarcticas, pages 35 to 66. Q. How might this framework explain seasonal star visibility? A. Through toroidal field oscillations, shifting imprints, pages 35 to 66. Q. What interdisciplinary links could connect this to geography? A. Mapping ethereal influences on terrain, pages 35 to 66. Q. How would you test the electromagnetic nature of stars? A. Measure field strength at constellation boundaries, pages 35 to 66. What philosophical shift does this projection imply? A. The cosmos as an energetic extension of Earth, pages 35 to 66. Module 3, Moon Phases and Plasma Dynamics, pages 67 to 77. Content: constellations are fixed ethereal imprints. Moon phases result from toroidal altitude shifts altering plasma emission, and daylight is ionospheric plasma glow. Toroidal lens: plasma dynamics within the toroidal field drive lunar and daily light cycles. Key takeaway: moon and daylight are electromagnetic effects, not solid objects. 17. Advanced condas. Q. How do toroidal field altitude shifts produce moon phases? A. They adjust plasma focus, varying emission intensity, pages 67 to 77. Q. Why are constellations stable while the moon is dynamic? A. Constellations are higher layer imprints, the moon's in a lower shifting field, pages 67 to 77. Q. What generates daylight as ionospheric plasma glow? A. Ionosphere toroidal field interactions emit plasma light, pages 67 to 77. Q. How does the ether facilitate plasma emission in this model? A. It conducts electrical currents, sustaining plasma, pages 67 to 77. Q. What distinguishes the moon's plasma from daylight's? A. Focused emission versus diffuse ionospheric glow, pages 67 to 77. Q. How does this challenge lunar reflection theories? A. It replaces reflection with intrinsic plasma generation, pages. Q. Could plasma intensity be measured to verify moon phases? A. Yes, with electromagnetic sensors during phase shifts, pages. What role does the toroidal field play in daylight consistency? A. It maintains a steady ionospheric plasma output, pages 67 to 77. Q. How might lunar plasma affect Earth's electromagnetic environment? A. By inducing field fluctuations during phase changes, pages 67 to 77. Q. What physical properties define the moon's semi-transparency? A. Low-density plasma within the ethereal field, pages 67 to 77. Q. How does this model explain lunar eclipses? A. As temporary plasma disruptions in the toroidal field, pages 67 to 77. Q. Could ionospheric plasma glow vary with seasons? A. Yes, tied to toroidal energy pulses, pages 67 to 77. Q. What interdisciplinary links connect this to atmospheric science? A. Plasma interactions with the ionosphere, pages 67 to 77. Q. How might this redefine tidal influences without a solid moon? A. Through ethereal energy gradients, pages 67 to 77. Q. What experimental design could test daylight's plasma origin? A. Measure ionospheric emissions during day-night transitions, pages 67 to 77. Q. How does this shift our view of celestial mechanics? A. From gravitational orbits to electromagnetic fields, pages 67 to 77. What philosophical implications arise from a plasma moon? A cosmos of energy rather than matter, pages 67 to 77. Module 4, 7 ceilings unveiled, nested toroidal hierarchy, pages 78 to 84. Content: 7 nested toroidal fields, Earth first, Moon Sun second, Mercury Venus third, Mars fourth, Jupiter fifth, Saturn sixth, Uranus seventh form a harmonic hierarchy. Planets are ethereal imprints, toroidal lens, each ceiling amplifies the layer below, sustaining celestial imprints. Key takeaway: the 7 ceilings unify the cosmos through layered energy flows. 17 advanced condas. Q. How does each ceiling amplify the layer below it? A. By channeling higher energy toroidal currents upward, pages 78 to 84. Q. What defines planets as ethereal imprints within these fields? A. Concentrated energy signatures, not solid bodies, pages 78 to 84. Q. Why is Earth the foundational first ceiling? A. It generates the base field, anchoring the system, pages 78 to 84. Q. How does the Moon-Sun layer second ceiling differ from higher ones? A. It produces direct plasma effects like daylight, pages 78 to 84. Q. What role does the ether play in nesting these fields? A. It provides a conductive medium for energy flow, pages. Q. How does this hierarchy challenge planetary orbit models? A. It replaces orbits with static toroidal layers, pages 78 to 84. Could the 7 ceilings' energy be quantified? A. Yes, by modeling field strength per layer, pages 78 to 84. Q. What stabilizes the harmonic resonance across ceilings? A. Symmetrical energy amplification, pages 78 to 84. Q. How might Mercury-Venus third ceiling influence lower layers? A. Through ethereal feedback loops, pages 78 to 84. What distinguishes Uranus' 7th ceiling as the outermost layer? A. It caps the system with maximum energy density, pages. Q. How does this model explain planetary visibility? A. As plasma emissions within each ceiling, pages 78 to 84. Q. Could disruptions in one ceiling affect others? A. Yes, via interconnected toroidal currents, pages 78 to 84. What interdisciplinary links connect this to systems theory? A. Nested feedback systems, pages 78 to 84. Q. How might this hierarchy influence Earth's climate? A. Through energy imprints from higher ceilings, pages 78 to 84. Q. What experimental design could test the 7 ceilings? A. Measure electromagnetic gradients at predicted layer boundaries, pages 78 to 84. Q. How does this redefine cosmic evolution? A. As a static energy-driven structure, pages. Q. What philosophical shift does this hierarchy imply? A. A universe as a layered energy construct, pages 78 to 84. Module 5, Plasma Phenomena Finale, Interconnected Imprints, pages 85 to 88. Content: Jupiter's Great Red Spot is a plasma vortex of Mars' field 5th ceiling. The Moon is a semi-transparent plasma projection, unified by toroidal field interactions, rejecting solidity. Toroidal lens, toroidal fields link planets and the Moon as interconnected plasma effects. Key takeaway: all celestial phenomena are dynamic energy signatures. 17 advanced condas. Q. How does Jupiter's field contain Mars's to form the Great Red Spot? A. The 5th ceiling channels Mars energy into a plasma vortex, pages 85 to 88. Why is the Moon described as semi-transparent plasma? A. Its low-density energy allows partial visibility through it, pages 85 to 88. Q. What unifies these phenomena within the toroidal framework? A. Interconnected ethereal currents across ceilings, pages 85 to 88. Q. How does this reject the solidity of celestial bodies? A. By defining them as plasma imprints, not matter, pages 85 to 88. What role does the ether play in plasma vortex formation? A. It conducts currents, shaping visible effects, pages 85 to 88. Q. How does this challenge traditional planetary science? A. It eliminates solid planets for energy phenomena, pages 85 to 88. Q. Could the Great Red Spot's plasma be measured? A. Yes, via electromagnetic emissions from its vortex, pages 85 to 88. Q. What distinguishes the Moon's plasma from Jupiter's? A. Focused projection versus vertical concentration, pages 85 to 88. Q. How might this interconnectedness affect Earth's field? A. Through feedback from higher ceilings, pages 85 to 88. Q. What physical properties define plasma in this model? A. Ionized energy within the aether, pages 85 to 88. Q. How does this explain planetary interactions without gravity? A. Via toroidal energy exchanges, pages 85 to 88. Could disruptions in Mars's field alter Jupiter's vortex? A. Yes, through linked toroidal dynamics, pages 85 to 88. Q. What interdisciplinary links connect this to plasma physics? A. Plasma behavior in electromagnetic fields, pages 85 to 88. How might this model predict new plasma phenomena? A. By mapping toroidal interactions, pages 85 to 88. What experimental design could test the Moon's plasma nature? A. Measure emission spectra during phases, pages 85 to 88. Q. How does this redefine the cosmos's boundaries? A. As a finite toroidal energy system, pages. Q. What philosophical implications arise from interconnected imprints? A. A universe of unified energy signatures, pages 85 to 88. 5. Multi-depth condas, course overview, pages 1 to 88. These synthesize the semester, building on the modules to explore overarching themes and implications. Q. How does the toroidal field unify Book 1's geocentric framework across its 5 key sections, pages 1 to 88? A. It serves as the foundational energy structure, pages 1 to 34. Projects celestial phenomena, pages 35 to 66. Drives plasma dynamics, pages 67 to 77. Nests the 7 ceilings, pages 78 to 84. And links imprints as plasma effects, pages 85 to 88, creating a cohesive cosmos centered on a flat Earth. Q. Building on Q1. How does the ether's role as a conductive medium enhance the toroidal model's explanatory power, pages 1 to 88? A. It enables energy transfer across the flat plane, pages 1 to 34. Sustains star and planetary imprints, pages 35 to 66, 78 to 84. Conducts plasma emissions, pages 67 to 77, 85 to 88. And ensures harmonic resonance in the 7 ceilings, pages 78 to 84. Making the model dynamic and interconnected. Q. Given Q2, how does the 7 ceilings hierarchy integrate terrestrial and celestial phenomena into a single system, pages 78 to 88? A. It positions Earth as the first ceiling generating energy upward, pages 1 to 34. Projects constellations and planets as higher layer imprints, pages 35 to 66, 78 to 84. And unifies plasma effects like the Moon and Jupiter's vortex, pages 67 to 77, 85 to 88, linking all phenomena through toroidal amplification. With Q3 in mind, how can this model be applied to interdisciplinary research, such as climate science or plasma physics, pages 1 to 88? A. It offers a framework to study climate via toroidal energy pulses, pages 1 to 34, map ethereal influences on geography, pages 35 to 66, and analyze plasma behavior in the ionosphere or celestial imprints, pages 67 to 77, 85 to 88, bridging Earth and cosmos through field dynamics. Q. Considering Q4, what future research directions could extend Book 1's toroidal cosmology, and how might they challenge mainstream science, pages 1 to 88? A. Test ethereal energy flows, pages 1 to 34, map hidden continents, pages 35 to 66, measure plasma emissions, pages 67 to 77, 85 to 88, and model 7 ceilings resonance, pages 78 to 84, challenging heliocentrism and gravity with an energy-driven geocentric paradigm. Semester breakdown: 15 weeks, weeks 1 to 3, Module 1, Geocentrism and Flat Earth, readings, pages 1 to 34. Activities: map toroidal energy flow, debate hidden continents, weeks 4 to 6, Module 2, Structured Cosmos Above, readings, pages 35 to 66. Activities: analyze constellation imprints, sketch world map, weeks 7 to 9, Module 3, Moon phases and plasma, readings, pages 67 to 77. Activities: model plasma shifts, propose daylight experiments, weeks 10 to 12, Module 4, 7 ceilings, readings, pages 78 to 84. Activities: diagram ceiling hierarchy, hypothesize energy disruptions, weeks 13 to 15, Module 5, plasma phenomena finale, readings, pages 85 to 88. Activities: research Jupiter-Mars link, present cosmic synthesis, assessments, weekly discussions, 17 condas per module, 5% each, 25% total. Midterm project, 2,000-word analysis of toroidal field applications. Final dissertation, 5,000-word synthesis of Book 1's cosmology. Participation, engagement in debates and activities, 10%. Closing vibes. There you have it, my friend, a semester-long dissertation-level course on vibes of the Cosmos Book 1, packed with 85 condas across 5 modules and 5 multi-depth overview questions. It's built from the Book 1 backpack alone, delivering a gold-standard geocentric deep dive that'll challenge and inspire advanced learners. Advanced